I always really like Docker, how powerful, scalable, easy and pleasant this tool really is, unlike, for example, Kubernetes. From my perspective as a DevOps engineer, composing new Docker image from the Docker file and then building and running with the various flags is always super fun. However, I have never been diving into the Docker security. So when I started to explore this domain, I quickly realized how important it is for the reliable application deployment to ship our containers in a secure fashion. Consequently, today's focus is Docker security and two subdomains related to it. Firstly, the most common threats, and secondly, how we can protect our infrastructure assets. This video is also the first one from the Docker security series, so if you are into Docker, Docker security or DevSecOps, stay tuned. Docker is also included in the LPI DevOps Engineer Tools certification. Click the link in the description to get 5% discount on the exam. Now let's come back to our training. Part 1. What are the attack surfaces? So the container attack surfaces is really a good starting point in our journey. When we talk about the attack surface, we are referring to all of the different points where an attacker can gain access or cause harm to our containers. We can really list few of them. So for example, misconfigured firewalls, open ports, vulnerable Docker images from the public repository, exposed Docker APIs, or accidentally leaking secrets in the environmental variables of our images. Each of these misconfiguration expands the attack surface and gives an attacker an opportunity for an exploit. Let's look closer at one of these surfaces, networking. Here we need to discuss briefly different sources of malicious traffic. Of course, the most dangerous way is the open internet that our misconfigured container can communicate via, for example, load balancer. Other sources of malicious traffic is for simply other container. Consequently, while we design our services in our infrastructure, we must be mindful about the fine-tuning networking settings in our containers. Apart from the sources of the malicious traffic, DevOps, Linux or cloud engineers should also be aware why container could have been infected. Again, here we can really have few entry points. For example, misconfigured inbound and outbound rules in firewall, lack of TLS or using outdated SSL configurations, weak or missing authentication, unrestricted ingress and egress policies. And the impact, well, it can be pretty deadly. For start, remote code execution, secrets and information extraction, lateral movement across our container network, and of course access to the database of our users that is hosted usually either in the container or on the host machine. Part 2. When container escapes. We've already discussed where an attacker can try to get in. Now let's discuss the most serious type of the attack, when one of these entry points is exploited. Let's discuss container escape. Container escape happens when a process inside the containers breaks out of isolated environment and gain access to the host system. And by access, I mean, for example, inserting kernel modules, reading etc password or etc shadow files, tampering with the logs, or even installing rootkits. So when the container is able to escape, it's not that only your container is infected. It's your entire server is under the attacker control, as the container shall share the kernel with the host OS. As we might already know, there are two kernel features that provides Docker with the isolation, and these are namespaces, and these really isolate the processes inside the container and indicates what container can see outside the container premises, for example, file systems, processes, host names, or networks. Another feature are the cgroup. So these control how much resources process can use, CPU, memory, disk I/O, etc. However, as I already mentioned, containers share the host kernel. So if an attacker finds a kernel vulnerability, example, I don't know, a bug in the system call, they can potentially escape the namespace boundaries and execute code on the host. The possible escape can happen through, for example, inappropriate privileges on the container. By running containers with the flags such as, for example, -- privilege, that can result in exposing containers to access sensitive host interfaces. Another way that can cause the container escape is the insecure configuration of seccomp, AppArmor, or Linux. So misconfigurations of these mechanisms can allow dangerous syscalls or allow access to protected resources. And then last but not least, we also have the kernel vulnerabilities. So of course we can exploit the syscalls such as, for example, unsure, clone, or mount from inside container to elevate privileges and as a result to escape. Now, let's discuss the following example of misconfigured container. So I run the container with the flag -- privilege and then mounting my kernel module that I wrote from my host to the container. And as the container is running with the privilege mode, that flag gives container all of the Linux capabilities, including capsys module, which allows loading kernel modules. Consequently, I am able to load the kernel module from the container and into the kernel. Later on, we can also see that the hello kernel module was loaded on the host. While it is extremely powerful, it's also very dangerous. We just perform an operation inside the container that changed the host kernel state. In the real attack, instead of the harmless hello module, an attacker can load, for example, a rootkit, a keylogger, or any other malicious kernel code. Part 3, how we can protect our infrastructure. Fortunately, for each layer of the surface attack, we can fortify our Docker with the specific protection mechanisms. I have divided the Docker security into the 4 core pillars. Let's discuss them one by one. Let's start with the Docker image security. So this domain is quite related to secure software development practices, because usually this is where we start when we want to containerize our application. We are writing the Docker file. So there are a few activities that we can conduct to make sure that our images are much more secure. So first of all, we're supposed to employ image scanners. So tools such as, for example, Trivy to analyze the Docker file from the CVE perspective. Scanners allows us to see what we can improve in our code and make sure that what we release is the best possible security quality. Another thing what we can do is just to use the official images. We use the verified images that are free from any potential vulnerabilities and allow pull from the known sources. Next, we also have the regular updates and rebuilds. We need to keep in mind that there are always few vulnerabilities discovered every day, so we need to make sure that we are patching and updating our images. Then, last but not least, we also need to be mindful while we are building the images to keep the images minimal. So meaning we need to avoid any extra software packages, heavy images, or extra exposed ports. So we here are supposed to use features such as, for example, multi-stage builds or distro-less images that are built from the scratch. Another domain that I would like to look at is the runtime security. Even with a secure image, how the containers runs matters as much. So here are just some runtime best practices. So first of all, resource limits. We're supposed to use flags such as --memory, --CPU, or --PID limit to prevent any DOS or noisy neighbor issues. Then we also supposed to drop the unnecessary capabilities. So here I would definitely recommend to use flags such as --cap drop that really helps us to reduce what containers can really do. And we also need to remember to avoid using flags such as --privilege unless absolutely necessary. Moving on, another advice I would give is, for example, running the container as a non-root whenever possible. The next domain is network security, and of course there isn't a single solution that can fix all of the network related vulnerabilities, But there are some things that we can do. So for example, first of all, we can use firewalls and network policies to isolate the traffic, disable or restrict inter-container communication unless it's really required, use TLS encryption for all of the internal and external connectivity, scanning the ports and remove all of the unnecessary services inside the containers. Of course, last but not least is, for example, monitor all of the unusual ingress or DNS activities that are really common in the container malware. Last domain is host and orchestration security. So here we also need to remember that because containers are sharing the kernel with our host system, we need to be mindful to patch and upgrade as fast as it is possible. And that's it for today. Thank you very much for watching, and I hope you enjoyed.